Okay, in this lecture we're going to talk about adding rational expressions together, and this comes from exactly the same way in which we add regular fractions. So for fractions such as, say, a over b and say c over d, where of course b and d are not equal to 0, then we're going to have the following things. A over b plus c over d, all right, is going to become a common denominator of b times d. So we'd need to multiply the top and the bottom here by d, plus c over d, and we have to multiply top and bottom by b, so we'll end up with ad plus bc over bd. Also for subtraction, all right, seeing subtraction really is the same as addition, just that we change the sign. So what we have here, of course, the same thing, AD on BD minus BC on BD. So we get AD minus BC over BD. Alright, so we're going to use this technique for rational expressions just like we did for fractions. So let's look at some examples. Okay, let's add or subtract the following. Right, let's do part A. Right, let's suppose we want to do 3 on 10x to the 4 plus 7 over 15x squared. Right, so we start to look for what the common denominator will be. Notice that we don't have a 10 in either of these. We don't have a 15 in either of these. So it's going to have to be a number that both 10 and 15 go into. And that, of course, will be 30. And so if I do 30, I have to multiply the bottom here by 3, which means I'd have to multiply the top by 3 as well. Plus, now to get a 30 here, I'd need to multiply by 2. And I'd have to do a 2 here. So what I end up with, of course, is 9 subtract 14 over 30x to the 4, which of course is negative 5 over 30x to the 4. And this of course comes out to be, finally, when cancelling by 5s, we'd end up with this result. Alright, let's do the second one. Alright, let's suppose we have 7 on a minus 4 plus 3a over 4 minus a. Right, now the thing to notice here, alright, is that 4 minus a and a minus 4 are the same, except they're in the reverse order. So if I was to take out a common, well, rather than a common, but just say a negative 1 here, I'd end up with this, and I'd take a negative by this here. So if I distribute the negative, of course, it becomes negative a plus 4 again, so that's what we have here. So this we could change into a subtraction, actually. And as you can see here, of course, this means we get 7 minus 3a over a subtract 4 would be the result. Alright, let's look at the next one. Let's suppose I have 4 divided by x minus 3 by x plus 5, and we're going to subtract 6 over x plus 5 by x take 5. Now we're looking for a common denominator here. We have an x minus 3, but we don't have one here. So we're going to have to multiply this one, the top and bottom, by x minus 3. Here we have a x plus 5, we have an x plus 5 here, so that's okay. Here we have an x take 5, but we don't have an x take 5 here, so we're going to have to multiply the top and bottom here. So if we do that first, I'd get this minus, and we have to do this one by x take 3. And we're going to run out of room here. X take 3 by x plus 5 by x take 5. Okay, so this will become, notice if I distribute on the top, okay, subtract, I'll do this in 2 steps, over x take 3 by x plus 5 by x take 5. So this becomes 4x take 20 minus 6x plus 18 over x take 3 by x plus 5 by x take 5. So this becomes negative 2x on the top, subtract, let's have a look, 2 over x take 3 by x plus 5 by x take 5. And so this, really we can't really do too much more other than maybe take a negative 2 out. And we end up with x take 3 by x plus 5 by x take 5. And that's the way we add and subtract rational expressions.